Welcome to the City Current Show. I'm your host, Jeremy Park. We're always honored to bring you inspiring stories of individuals and organizations making a difference and powering the good. And we love talking about entrepreneurialism, innovation, and definitely in this case, also too, taking care of our environment, our world. We're honored to be joined by Bryan Eagle. He's the CEO and co-founder of Glanris. Bryan, how are you doing?
I'm doing great. Thanks for having me on. It's Earth Day, so this is the perfect day to be talking about what we're doing.
Absolutely. Yes, indeed. Let's start with a little bit of your backstory. And when you talk about being the CEO and co-founder of Glanris, talk about where this idea started.
Sure. So it started actually at CBU here with a professor at CBU that was really trying to explore what can we do with all the ag waste that we generate every year across the river in Arkansas. And he looked at a bunch of different ag waste products, and it turns out that rice hulls, which is what we use, has some very interesting physical and chemical properties that make it an excellent choice for water filtration.
And so talk about where the name comes from, Glanris.
Yeah, so Glanris is actually Gaelic, and it's Glanris, which means clean rice. And that's what we're doing. We're trying to clean up the world and water through rice byproducts.
And so let's go ahead and dive into the science of this, because obviously, it sounds almost like too good to be true. It's simple. It's taking what, is ag waste on one side, but then all of a sudden you're able to turn it into something powerful to power the good. So talk about the science of this and how it works.
Sure. Yeah, we get that a lot. Sometimes the simplest solutions are the best solutions, and this actually has very powerful ramifications in a number of different areas for the planet. Right. So keeping in the theme of Earth Day, we should talk about that. But what we do with the rice hulls, just to kind of give a little bit of explanation on it, is we take the rice hulls. That's about 30% of the harvest of the rice harvest. So it's a significant byproduct, and today that's a waste product. It's either burned or it's hauled to the landfill. If it's burned, it produces carbon dioxide. If it goes in the landfill, it produces methane. So neither one of those things are exactly environmentally friendly. And across the river in Arkansas, just to sort of put it in perspective, we grow about 50% of the rice grown in the United States, right in Arkansas. And they produce over 2 billion pounds of rice hulls every year. It's a major component in landfills in Arkansas right now. So, what we do is we're working with our partners, Riceland Foods, which is the largest rice co-op, to take that and through our patented process, pyrolyze it and turn it into this water filtration medium. So what's pyrolization? Well, pyrolization is where we basically cook it at very high temperatures in the absence of oxygen. So we don't burn it, we carbonize it basically, which is what happens. So you cook off everything else in there. All the carbohydrate material gets turned into carbon. And then we activate it. You probably heard the term activated carbon. That's used globally today for water filtration. So we turn it into an activated. Once we turn it into a carbon, then we activate it, which is really nothing more than sort of steam washing it to clean out the pores of it. And then you have this carbon structure. When you think about that, in terms of, well, how does that filter water? When you look at it under a microscope, it's like a sponge. And all of those holes have these adsorbative properties that allow it to pull organic material out of the water and hold on to it. So it's very good at removing organics. However, doesn't do anything for metals, lead, chromium, the bad stuff. And that's where our uniqueness comes in, because rice hulls are very high in silica, and we're able to build some unique chemistry through our patented process that gives us the ability to not only remove organics the way activated carbon does, but also remove dissolved metals through an ion exchange capability that we add onto it. And while that sounds, complicated, it's actually pretty easy to do. And our material is completely safe. You could eat it if you wanted to. I don't know why you'd want to, but you could if you wanted to. So very natural process, very simple process to do as well.
What does the scalability and the usability look like in terms of residential homeowner, cities,
right,
other countries? Like, talk about kind of the broad applicability of this.
Right. So in the water filtration world, there are basically three different markets. There's the industrial market. This is any manufacturing firm that needs to clean up their wastewater. There's the municipal market, which is both producing drinking water as well as cleaning up wastewater. And then there's the residential market, the pitcher filter type systems. We actually have a play in all three of those. In the industrial world, we're anybody that has metals in their manufacturing process and uses water to clean that up. So anybody that paints, plates, bends, scrape, does anything with metal, and uses water to clean those up, or uses water to clean up the plant or the machines or whatever, is going to end up with metals in their discharge. And they need to remove that before they can, discharge their water, or hopefully through our process, reuse that water. Because ultimately what we want them to do is to be able to use our material to sustainably clean that water, because water can be recycled indefinitely, and then ultimately reuse that water. So, we got that market. We're also getting a lot of traction in environmental remediation, because our material, again, removes organics and metals. We also don't foul in the presence of oils and grease. We operate at much wider pH ranges than what you normally see with the typical metal removing technologies. So people who are going out to clean up a mess, they don't know what they're going to get into. And we have this sort of broad spectrum filtration capability, which includes, adsorption for organics, ion exchange for metals, across a very broad spectrum of contaminants. So, we're getting traction there. That's kind of our initial market. The municipal market, we've got 4 customers now in the municipal space. And these are basically large, big vats of this stuff. And the water flows across it. And as it flows through that material, it gets filtered. And that market is a huge market, very slow to adopt, because if you get it wrong, you can get people sick or worse. So, they're very slow, very cautious, which is a good thing. Frustrating for us as a new company, but a good thing for you as consumers that, most water municipalities take a lot of care in researching what they're doing. And we're going through that right now. We won these municipal contracts back in December. We're not actually going to deploy and install this stuff until beginning of next year, because there's lots of testing that we've got to go through just to make sure that at each different level, there's nothing that we're doing that will contaminate the water. And we've gone through, some of the big first steps in all of that, which is this certification that you have to go through called NSF 61. No, that doesn't mean anything to anybody, but basically what that means is that we don't leach anything toxic into the water, and we can filter to EPA standards. And that's an important sort of first hurdle, big major hurdle to get everybody comfortable about, oh, okay, this is really serious stuff here. And then on the residential market, the last market, think about the pitcher systems that you have out there, like, that have these sort of filters in it. What's in here is about 60% activated carbon and 40%, 60% ion exchange resin bead and 40% activated carbon. And we can replace both of those with something that is organic and non-polluting. So we're very excited about this market, and particularly about partnership we have with one company, because if you have one of these types of filters, you throw this whole thing away, the plastic housing and what's in it. And that ion exchange resin bead is a petroleum-based microplastic. But these guys have a very interesting product. So you can unscrew this so that you're not throwing this away. And inside there is a filter pod, which would contain our material. So now you have a much greener way of filtering your home water.
Yeah, very, very cool.
This plastic.
Talk about recently on your end, the technology was declared net CO2 negative. So what does that mean when you talk about carbon dioxide and kind of that right. Sort of kind of seal of approval, but also too, just being declared that, what does that mean?
Yeah. So what that means is that in our process, we use less energy and carbon dioxide than we sequester. So again, when we turn it into that stable carbon, it will not break down. It will not go back into the atmosphere as carbon dioxide or methane for hundreds to thousands of years. And so what's good about that from a climate standpoint, you've heard a lot of talk recently about, we really need to address climate change through carbon sequestration and all these things that people are talking about. Well, really what that's about is about taking carbon dioxide out of the atmosphere. Now, there's a normal carbon cycle. The carbon cycle is, plants grow, and through photosynthesis, they pull in carbon dioxide into the plant structure to create the carbohydrate plant structure, and they give off oxygen, right? And then they die. And when they die, it sort of releases it, and that's the carbon cycle. Well, to make the plants that we have, the trees that we have, and the other sort of natural filtration systems that we have here on the planet more effective, what you need to do is you need to pull the existing carbon dioxide out of the air and put it back into the ground. Today, a lot of activated carbon, most of the activated carbon that people use today is made from coal. So you're digging it up out of the ground, activating it, and then we should stop that. Take these plant waste materials and rice hulls. Again, we talked about 2 billion pounds in Arkansas, 220 billion pounds worldwide. It's the largest ag waste product in the world. Take that, convert it into carbon, use it to filter water to help address the water crisis out there, help people reuse that water by giving them sustainable tools to filter it, and then put that carbon back in the ground in landfills or wherever you end up putting it back into the ground and sequester it. So now you've got this double duty, right? You're dealing with the ag waste, you're helping to clean up the atmosphere, and in a sort of 1-2 punch with something that, oh, by the way, is less expensive than ion exchange resin beads today. So, we're about a quarter the capacity, but we're 1/15 the cost. So on a cost per gallon of water filtered, we're much less expensive. So there's no green premium to this, no excuse not to try it, right? And it's a drop-in replacement for the type of filtration systems that exist today. So you don't need to buy new hardware. You don't need to change out what you're doing. You just simply take those ion exchange resin beads and activated carbon out and replace that with our material.
How does this play a role when you talk about like carbon credits and all of that sort of conversation? How does this play into that?
Yeah, so we actually create carbon credits because we're carbon negative. And carbon credits, the voluntary carbon market was created to provide an incentive for people to basically do the things that we were talking about, which is to do carbon, these sort of abatement processes, which is reducing the amount that you do, or sequestration processes, which is putting it back into the ground so that it's pulled out of the carbon cycle. And so these carbon credits are, incentives, monetary incentives for companies who have carbon negative processes like ours to get started and to produce material.
What's been the biggest challenge, but also kind of the aha, this is an amazing opportunity on both sides? What's been the challenge for you as an entrepreneur, but at the same time, looking ahead, what puts a smile on your face is an opportunity?
Well, I think the biggest challenge we sort of talked about, and that's that the water industry is a still pond. It's not a rushing river. So, as a guy that came from, a telecom and software background, these are things that, you want to get moving on quickly, right? Like the old adage, move quick and break things, right? You don't do that in the water industry. You move very, very cautiously, because for them, it ain't broke and they ain't interested in fixing it. And, but it is broken. It's broken because they're not using environmentally friendly tools to deal with these problems, and they need to sort of wake up to that. But it's a process. So, that's the frustrating thing for me, is how slowly this industry moves. In terms of what is the aha moment. I think there are a bunch of these sort of wow moments that we've had along the way, but it really is towards the efficacy of the product and the reach that this stuff can extend into. That's really for us been sort of the surprise, is how far-reaching this is, because this is a global product. Anywhere rice is grown, and it's grown everywhere, you can locally produce this product, which is a key thing, again, in sustainability, is not, for us to produce it here in Memphis and then ship it to Vietnam. No, they ought to be producing it in Vietnam. That makes a much greener product. And so we've got, literally dozens of people around the world that want to partner with us to do this. And we're raising money right now, and part of the use of proceeds for that is obviously to be able to expand globally.
Yeah, I think the potential on this is absolutely limitless. So what's one more thing that you want everyone to know? And maybe that ties into how can we help in terms of investment and obviously just raising awareness for what you're doing. But what's one more thing that you want us all to know?
Well, I think the key thing is we can all play a role in this, right? Today's Earth Day, and look in the not too distant future for this product. We'll be back to talk to you more about that, because that's a simple thing you can do that has far-reaching effects. Not throwing this plastic away, not putting those ion exchange resin beads into the trash, where they end up, again, as we've all heard about, animals eat it, fish eat it, we eat them, that ends up in us. I mean, it's not a good thing. So these small changes that we can make, and it won't cost you any extra, can have far-reaching effect and help to save the planet.
We'll wrap up with website, contact information. Where do we go to learn more?
Yeah, so if you want to learn more about what we're doing, feel free. hello@glanris.com is the email, and the website is www.glanris.com. GLANRIS, Glanris, clean rice.
You make it easy. Well, Bryan, congratulations. I love what you're doing. Thank you for coming on the show.
Well, thanks, Jeremy. I appreciate it. Happy Earth Day.